Number 1 says that the knitting club sold 40 scarves and hats for the winter festival and made $700 from the sales. They charged $18 for each scarf and they charged $14 for each hat. If S represents the number of scarves sold and H represents the number of hats sold, which system of equation represents the constraints? So in this, before I kind of look at these, I like to write down that the total number of items is 40 and that the total money is 700. So those are kind of the two numbers that I'm looking for these equations to equal. So in A, that would not work out because there's two 700s, where B has one equal to 40 and one equal to 700. C also has one equal to 40 and one equal to 700. And D only has 700. So when we're looking at 40 being the total, 40 is the total of the number of scarves plus the number of hats, not the money that goes with them. So this one has it with the money equal to 40. So we want C. The number of scarves plus the number of hats is 40. $18 times however many scarves we sold plus $14 times however many hats should equal $700. Number 2, here are two equations. Decide whether each XY pair is a solution to one, both, or neither of the equations. So we're going to just plug these in. So I'm going to do this first equation in purple. So we're going to do we're going to do 6 times the X value. So 6 times 3 plus 4 times the Y value, which is 4. And that should equal 34 if this is a solution. So 6 times 3 is 18. 4 times 4 is 16. 18 plus 16 does equal 34. So this is a solution to that first equation. So then let's take a look at that ordered pair in the second equation. So that would be 5 times 3 minus 2 times 4, and that should be 15. So 5 times 3 is 15. 2 times 4 is 8. So 15 minus 8 does not equal 15. So this is a solution to one of the equations. Part 2 is going to be 6 times 4 plus 4 times 2.5, and that should equal 34. So plugging into that first equation. So this is going to be 24 plus 10. And that does equal 34. So that's a solution to that one. Then we're going to plug it into equation 2, which is 5 times the X, which is 4, minus 2 times the Y, which is 2.5, and that should equal 15. 5 times 4 is 20. Negative 2 times 2.5 is negative 5. 20 minus 5 is 15. So this is a solution to both equations. And then I'm just going to make these smaller here so I can fit the next ones. So then the third one, we're plugging in 5 for X and we're plugging in 5 for Y. So we're doing 6 times 5 and 4 times 5. And that should be 34 if it's a solution. And this is 30 plus 20, which is not 34. So it's not a solution to the first one. And then the second equation, we would do 5 times our X, which is 5, minus 2 times our Y, which is 5. And that should equal 15. So this is 25 minus 10, which does equal 15. So it's a solution to one equation. And then the last one, we would do 6 times 3 plus 4 times 2 to see if that's 34. And that's 18 plus 8, which does not equal 34. And then in the second equation, it would be 5 times 3 minus 2 times 2. And so that's going to give us, or should give us 15 if it's a solution. And this is 15 minus 4, which does not equal 15. So this one is a solution to neither equation. So then, is it possible to have more than one pair of solutions to this system, and explain your reasoning? So this is not possible. Okay, so not possible. No. So no. It is not possible to have more than one point be a solution to a system, because each equation represents a line. So because each equation represents a line, and two lines can only cross at one point, at most at one point, right? They could not cross at all if they were parallel, but two lines are only going to cross once. So if we take a look at this, and actually let me do purple. So the purple equation, and I don't know what it looks like, but if I just draw a purple line and then I draw a blue line, they're only going to cross at one point. So there can only be one solution for both equations. All right, number 3 says explain or show that the point 5, -4 is a solution to this system. So that means it needs to be a solution in both equations. So we'll plug it into the top equation here. So we'll do 3 times 5 minus 2 times -4 and see that that's 23. So this is 15. -2 times -4 is +8, which is 23. When you do 15 plus 8, that's 23. So that means it's a solution to the first one. In order to be a solution to the system, it has to work in both equations, or it has to be a solution to both. So we'll plug it into the bottom one. So 2 times 5 plus -4 should be 6. So this is 10 minus 4, which is 6, and 6 equals 6. So this is a solution to both equations, meaning it's a solution to the system. All right, number 4 says that Diego is thinking of two positive numbers. He says if we triple the first number and we double the second number, the sum is going to be 34. Write an equation that represents this clue. So if we take 3 times whatever his first number is, we'll call it x. And then we add, because we're doing the sum, 2 times whatever the second number is, which is going to be potentially different than the first. So we'll use different variables. That total should be 34. And then find 2 possible solutions to this. So I know that this is an even number, so both of these need to be even. So if I pick a value for x, I want this to multiply to an even number. So let me just pick 2. So if I do 2 times 3, or 3 times 2, that's 6. We know the total needs to be 34. So I'll subtract that from the total. So this 2y portion needs to equal 28. So divide that by 2 and we get 14 as that solution. We could plug in 10. So 10 times 3 would be 30. So then we'll do 34 minus the 30. So then the 2y portion needs to be 4. So 4 divided by 2 is 2. So those are 2 solutions, and you could come up with a lot more than that, but that's just 2 that I came up with. Then Diego says if we take half the first number and double the second, the sum is 14. So write an equation for this clue, and it's the same set of numbers. So we're going to take half of the first number, which was x, plus 2 times y, or the second number, and now the total is 14. Then it wants us to figure out what are Diego's numbers, and we can use this graph to help us. So I'm going to graph the points that we figured out from the first clue. So 214 is a solution to that one. Also 10-2 was a solution. And I'm just going to, then you can just use a ruler to connect those 2 points. to make sure that you have a straight line so you can see all of the points that it's crossing. So you want to be precise on that. Then for this next one, we can graph a couple of points. So I'm going to do actually the y-intercept and the x-intercept. So if I do 1/2 x and I plug in 0 for y, I get 14. So then I'll do x equals double that. So x equals 28, which is off my graph. So that's not going to be helpful. And the y-intercept is going to be 2y equals 14. So y equals 7. So that one I can graph here. I could also just come up with a couple more possible answers, right? So I could do, let's say that x is 10. So let's do 10 for x. So if I do half of 10, that's 5. So then we know that if we take 14 minus 5, this next part is going to have to be 9. So if we do 14 minus 5, then 9 would be your 2y part. So at 10, we're going to be at 4.5. So that's not really super helpful to graph. So we could pick another one. So we could do 6, and half of 6 is 3. That's going to be a bad one too. Let's do 8. So if I plug in 8 into here, so half of 8 is 4. So then 14 minus 4 gives us 10, which is for that 2y part. So then this will be 5. So then the 0.85 will be on here. And really that one looks like the intersection here. But so if we graph this line that connects this one to this one, that would be our second equation. And then those ones actually appears to be the solution here where they cross. So the 0.85 appears to be the solution, and we can plug it into this first one to see. So 3 times 8 plus 2 times 5, does that equal 34? So this is 24 plus 10, which does equal 34. So that's the solution. 8.5 is a solution to both equations. Number 5, the table shows the volume of water in a tank after it's been filled to a certain height. Which equation could represent the volume of the water in cubic inches, V, when the height is H inches? So they give us this table, and we just kind of want to plug them into this formula. So does the height equal the volume? Only in this first case. Otherwise, 1 doesn't equal 1.05, 2 doesn't equal 8.4, so this one doesn't work. H equals the volume divided by 4. So if we take the volume and we divide it by 4, do we get back to the first one? Only in the first ordered pair. Only 0 divided by 4. 1.05 divided by 4 isn't 1. So that doesn't work. Then this next one, so we're not going to let's not plug in 0 because it's going to work. Well, it's actually not going to work in this one, so we could plug it in because the volume is 0, and then 0 squared is 0 plus 0.05. So 0 equals 0.05 is false. So that one's not going to work. And then for part D, so let's just check a couple of them. So let's actually check when we cube the first number. So 1 cubed times 1.05. And 1 cubed is 1. 1.05 times 1 is 1.05. So that one worked out. And then let's plug it in another one. So let's plug it into this one. So then we'll get 1.05 times the height 2 cubed. So 1.05 times 8. And 1.05 times 8 is 8.40, which also works. So this is our equation. Number 6, Andre does not understand why the solution to this equation must also be the solution to this equation. So write a convincing argument as to why that's true. So the equation, if we take 3 minus x, and we multiply that by 3, and then we multiply the 4 by 3. So we just multiplied both sides by 3. So I'm just going to write that in. we get the equation. So if you do 3 times 3, you get 9. If you do 3 times -1, you get -3x, and then equals 12. So if we just multiply both sides by 3, we get this equation. And this equation is equivalent to, if we said 12 equals 9 minus 3x, if we just move it across the equal sign. So the equation 3 minus x equals 4, and 12 equals 9 minus 3x are equivalent to each other. So they share the same solution. So if two equations are equivalent, that means that they share the same solutions. So, and we know that these are equivalent because we just multiplied both sides by 3, which gave us the same equations. So then they're going to have the same solutions. Number 7, volunteer drivers are needed to bring 80 students to a championship baseball game. The drivers either have cars, which have 4 seats, or vans, which have 6 seats, and it's modeled by this equation here. So explain how we know that this is the graph. So how do we know this is the graph of 4c plus 6v equals 80? So there's a bunch of different ways that you could do this. You could identify some points on here. So this is the point 212, and you could plug it in, and then you could identify another point. So this looks like 8, 8, and plug that in to show that those are two solutions of the equation, and any 2 points make a line. So if you plugged those in, you could also look at finding the vertical intercept, which means that your cars would be 0. So just your vans would give you all 80 seats. So when we divide by 80 here, or sorry, when we divide by 6 here, you get that the number of vans you would need is 13.33, which doesn't make sense in context because you can't have a third of a van, but we can see that it does cross here at 13.3. And then if we did the horizontal intercept, that would be where we don't have any vans and we only have cars. Okay, so no vans, only cars. So then you would just solve this. So divide by 4, and we would get that we would need 20 cars if we had 0 vans. And we can see that it crosses at both those points. So that would be another way to show that this is the line. You could also solve it and look for the slope. So there's a lot of different ways you could prove that this is the line. Number 8, 3 siblings are participating in a family-friendly running event. The oldest sibling begins at the start line. Okay, so she's starting at the start line, and she's running 7 miles per hour the whole time. Then the middle sister, or the middle sibling, begins at the start line again and is running or walking 3.5 miles an hour throughout the whole race. Then the youngest sibling joins the race after 4 miles. So their start time, they're starting at 4 miles, and then they're running at 5 miles per hour the rest of the way. So one thing, and now we just want to match these lines to it. So you could be looking at remembering that this is the starting point. Okay, so your X or your Y intercept is your starting value. And so this youngest sister started after 4 miles, where the other 2 sisters or siblings started at the start line. Okay, so then the start line is going to be here. So this means that we know that graph A is for the youngest sibling because it's the only one that didn't start at the start line. Then you can go over to the 1 mile mark. And after 1 mile, this graph was at 3.5 miles. And at this one, they were at 7 miles. So this is in 1 hour. So this tells us their speed. So that means that graph B is running 7 miles per hour, which was our oldest sibling. And then graph C is going at 3.5 miles per hour, which is our middle sibling. Number 9, what is the x-intercept of the graph? So remember, your x-intercept is when your y-coordinate is 0 because you're somewhere here on the x-axis. So you haven't moved up. So your y value is still 0. So we will plug y equals 0 into this equation. So 0 equals 3 minus 5x, and then we can solve for x. So I'm going to add 5x to both sides. 0 plus 5x is 5x. And then we just get 3 plus 0 here. And then we can divide by 5. And we get x equals 3/5. And so remember, it's the x coordinate. And this is your x and this is your y. So really, these ones weren't x-intercepts because they're on the y-axis. So it was down to one of these two. And then we figured out that it was 3/5 0.